Okay, so we are going to move on to 5.3, which is called Can You Say It with Symbols? So, math, there's a lot of symbols. Yes, I figured that out. Okay. So yeah, you can say a bunch of stuff with symbols, and in actuality there's even more symbols that you will all learn in a little bit. So but first, here is a jump start. So it says here's one more diagram for you to examine. Describe the sequence of steps you think were used to construct this diagram, beginning with the first figure and ending with the second. So we started here, something happened, and then we got here. And then they continued and they got here. Okay. So which segments or lines do you think happened next? Which segments happened next? Actually, for this one, what do you think was the first one that they drew? Yeah, they drew A. Good. And then what did they draw? Yeah, they drew B. Very good. So they drew this segment AB. Very good. And then what happened? And then, yeah, and then they drew this line here. So a couple things here. You can call a line by the points on the line, AB, but this is actually a segment. So segment AB. You can also call a line by a lowercase letter like this, and it'll usually be by the arrow, so it's L. Okay, so then they drew in line L. Notice line L did a lot of things. What are the two things line L did? What are the two things that line L did? What do you see? Yeah, so it split it down the middle. What's the mathematical word that we just learned instead of saying split? What was the mathematical word we used? Yeah, bisect. Very good. So L bisected, bi means two, sect means sections. L cut AB into two congruent sections. You guys all see this? They're congruent. Good. Okay. It did it perpendicularly too, though. It did it perpendicularly. Very good. And then what happened? What did they draw next to get this picture? What did they draw next to get this picture? Yeah, they drew AC and BC. Anybody want to take a guess about what they're drawing in this picture? Anybody know what else the what else do you wonder about this? Oh, it looks like a plane. That's funny. I didn't even think of that. Very good. Do you see this triangle? Good. Maybe they're maybe they're gonna draw a cute little house. I agree. Why not? Very good. Anybody see anything else here? Hmm. How many triangles do you see here? Oh, the little square means that it's perpendicular. This little guy means it's 90 degrees. Yeah, there's three triangles. Very good. So for those of you who only see two, you probably see left and right. There's this triangle too, ABC. Does everybody see that? Yeah. So what's really cool is when you guys start seeing all those things. Now, like some of you are like, seriously, Mr. London, who cares how many triangles they see? If you are having an issue seeing how many triangles there are, do you see how it's going to be a problematic later? Does that make sense? All right, very good. Let's move on. So there's going to be notation, there's going to be vocabulary, and there's going to be something called conventions. Do you guys know what a convention is? Convention. We use this phrase like it's by convention. By convention. Have you guys ever heard that phrase? Oh, oh, not a different kind of convention. Sorry. Some people think like not like the convention center in downtown, not like that. A little different, right? So a convention is like when I say something, it's like by convention. Like when I say red, what does red mean to you guys? Yeah, red means stop. But does red actually mean stop? No, it's just by convention. Someone's so cute. Love. It means love, Miss Johnson. Yes. So red by convention means stop. Okay, let's continue. Green means what? Yeah, green means go, but not because green means go. It's just that, or slime. Oh my gosh. But green means nothing. Green is just a color. But because we've attached this meaning to it, now it means go. Oh my gosh. Apparently, green has more like stuff to you, has more meaning. I've gotten slime, boogers, and St. Patrick's Day. Okay. Apparently, green has a lot of meaning. So, by convention, it's how we set things up like a long time ago. And I don't know what a long time ago means. It just means before we started learning it and talking about it. Does that make sense? Like this letter right here, that doesn't mean A, but we've all attached like, oh, that's the letter A. Does that make sense? So it's by convention. Someone set it up way long ago for us to do it. Okay, so the next thing that I want to show you. So if I asked you, what do you think a perpendicular bisector is? What do you think a perpendicular bisector is? What would you guess it to be? Just your best guess. Just best guess. Best guess. Very good. It's a segment or a line that bisects something perpendicularly. So this is why I like math. I like math because they name things appropriately, right? Like for example, a perpendicular bisector is a line that bisects something perpendicularly, also known as this guy. So this guy is a perpendicular bisector. Why, Miss Johnson? Do you see the perpendicular? Everyone says yes. Do you see that it bisects it? Yes. So this line L is called a perpendicular bisector of AB. It's a perpendicular bisector of AB. So I want to show you a couple of symbols just so that we're all on the same page. The way we say perpendicular in math, if I want to do a shortcut, is an upside down, looks like a T, but it's supposed to be perpendicular. If Miss Johnson drew it better, it would look more like, oops, sorry, let's try again. Looks like that. So that's how you write perpendicular. So a perpendicular bisector of a segment is, let's type this out, is a segment or line that intersects the segment at its midpoint and forms right angles. This is Miss Johnson's shorthand. It's not perfect, but so it's a segment or line that intersects the other segment at its midpoint and forms right angles. Okay, wait, what? Miss Johnson, what's a midpoint? What is a midpoint? Any guesses on what a midpoint is? Any guesses on what a midpoint is? Yeah, it's the point in the middle. Perfect. Boom. That's the midpoint. Why is that the midpoint, Miss Johnson? Because it's the point in the middle. Okay, so today you're going to be able to organize and sequence proof statements using a 2-column format. You're going to examine a claim about points on a perpendicular bisector of a line segment. Okay, you'll be able to answer these questions. How do I keep track of all the statements that need to be recorded in a proof? How do I attend to the order of the statements in a proof so that the ideas that need to be established first come before the statements that require that prior information? So you're going to be able, this is like day, I don't know, maybe 3 of proofs. Okay. You don't realize that since we've started this chapter, you have been writing proofs, except we haven't been writing them. We've been talking about them. So in order for you to write something, you have to be able to talk about it. And in order for you to talk about it, you have to be able to think about it. So all those times that I put something in front of you and I was like, okay, what do you see? So you have to be able to see it. So what we're going to do is we're going to try a strategy that's called 3 reads. So the very first read, you're going to read the statements and examine the diagram. I'm going to send you off to groups and you're going to describe the details of the context. And the partner is responsible for filling in any details that were overlooked. Okay, so the very first one that we're going to do, we're going to read this one together. And then I'm going to send you off in pairs. I'm choosing pairs. I'm going to send you off in pairs so that you guys can fill in your statements. Eventually, it's going to look like this thing. This is a proof. It's really tiny. I'll use my own thing, but anyways. So we're going to read this one, and then we are going to come back again, and we're going to make sure that you understood it. Okay, so I'm going to start with this. Tia and Tahani are doing their math homework. Okay, they're together. They're doing the math homework. One of the problems is to prove the following statement. So in a proof, you're going to prove something. So here's what you're going to prove. Okay, based on this diagram or any information that they give you, you're going to prove that the points on the perpendicular bisector of a segment, where's the perpendicular bisector of the segment? Which letter are we talking about? Which one are we talking about? AB or line L? Very good, line L. L is the perpendicular bisector. Okay, so then I'm going to put an L here. So the points of the perpendicular bisector of a segment are equidistant. What? What is equidistant? So hold off on that question. Good question, by the way. From the endpoints. What? What are endpoints of a segment? Okay, segment just means part of a line. Okay, so let's do endpoint first. Who's the segment in this picture? Who is the segment in this picture? Very good. A, B. Now I'm going to put a little hat on AB, telling everybody that it's a segment. Okay. If I put this hat on AB, it just means it's a line. So instead of it starting here and ending here, it's going through here and through here, like that. Goes through. Okay. So the points on the perpendicular bisector, L, of a segment are equidistant from the endpoints. What are endpoints, Ms. Johnson? What are endpoints? Just guess for me. What do you think endpoints are? What do you think endpoints are? Yeah, where the point, where it ends, right? Okay, name them. In this picture, name your endpoints. Actually, for this segment, no, not that letter. So if this is the segment we're talking about, AB, yeah, it's A and B. Everybody okay with that? A and B. Not L. L is actually the name of the whole line. You'll know points, right? By capital letters. Yeah, good job. Okay, so what do you think equidistant means? What word do you see here? Equidistance. What words do you see? Very good. I see the word equal. Why am I writing the word equal? I'm going to put equal. Equal. Very good. Equal and distant. So what? Hold on. Let's read it again now that we understand. Okay, so the point on the perpendicular bisector, which is this guy, L, everybody see my L? Of a segment. So the point of the perpendicular so a point. I'm just going to choose one. I'm not going to think about all of them. I'm just going to choose one. Like this one right here? Sure. So that little red point is equidistant. So it's equally distanced from the what's? Oh, from A and B. I can't draw lines. Let's try that again. Boop, boop. Okay, let's try. Okay, from here to here and from here to here. Okay, they're equal distance. How do I mark it so that it's equal distance? What do I do? What do I do to show that they're equally distant? Anybody remember this? Yeah, very good. You just put little congruent tick marks. So you're going to prove that no matter what point is on there, these are congruent. So you're going to go talk to your partner right now, okay? And you're going to try to talk to them about what they think, number one, this is about, but number two, how we're going to prove that. Okay? So I'm going to pause. Okay, so now we're back. And I wanted to hear from you all. Does any I saw some of you already came back and you're like, I know how to prove it. Okay. So so you are going to prove, or together we're going to prove that the points on the line, basically that AC is congruent to CB. AC is congruent to CB. So does everybody kind of see why they think that it would be congruent? Does everybody kind of agree? Yeah, that looks congruent, Miss Johnson. Does everybody agree with that? Yeah, right? Okay, very good. Someone said, Miss Johnson, I see the reflection again. Very good. So when they reflect like this, you're just going to check a couple things. Okay. Specifically, you're going to look for congruent things to say, oh, these are congruent. You'll already see that this is congruent to this. Does everybody see how those are congruent? Does anybody else see anything else that's congruent in this picture besides this section and this section? And I'm just going to add the letter D in there so that I can talk about it. Like, does anybody see anything besides AD congruent to DB? Does anybody see anything else? Point C is equidistant to point A and B. Yeah, that's actually what we're proving, right? We're going to prove that these two are congruent. But before we do that, we need to prove a couple more things. There's one more thing that is congruent that I see besides AD is congruent to DB. Does anybody see anything else that's congruent? I'm just going to snap a picture of this because I'm going to use it in a second. Yeah, it's a midpoint, but there's one more thing here. What have you not talked about besides the fact that this is a midpoint, the fact that this is congruent to this? There's one more thing. Yeah, there's one more thing. It has to do with, look at all the symbols. Have you talked about all the symbols in here? What's something that you haven't talked about? We talked about the little tick marks. We did. No, the arrows just means that the lines go on forever. Come on, y'all. Find it. Yes, very good. It's perpendicular, Miss Johnson. We didn't talk about it's perpendicular. Because it's perpendicular, who else is congruent? Who else is congruent? So this side is congruent to this side. I'm going to tell you right now, it's the angles. So this angle in here is congruent to this angle in here. So whenever you have lines that are perpendicular, the angles that you should see are all congruent. Okay, so I'm going to go over this super quick because we don't have a lot of time. So I want you later on to read through this, and your job is up here. Let's see. In the table, record in symbolic notation when Tahani may have written to keep track of Tia's statements. In the examples given, note how Tahani is introducing symbols for the lines and the points in the diagram, so she can reference them again without using so many words. So notice here, she wrote segment AB. Does everybody see that? Okay, here's what we're going to prove. We're going to prove that we need to show that this point is the same distance away from the two endpoints. So we're going to work on this the next time. But if you can just read through all this to make sure that you're comfortable with some of the notation like AB, some of the notation like line L, so that you are ready for next time. Good? All right, I will see you